Hey everybody, I'm going to solve the problem broken calculator, which is leetcode 991. So let's understand the problem. So we are given a calculator calculator which has some initial value, which is some value, let's say start value, and we have a target number, and then only two types of operations are allowed in this calculator for this initial start value. So either we can multiply this number by 2, or we can subtract 1 from the value, right? So doing this, we have to reach to the target number, and the constraints is that both start value and target number are between 1 and 10 to the power 9. Okay, so how would we solve this problem? So let's run with an example. So let's say we have a start number 5 and we have a target 8. So what is the minimum steps in which we can reach to this target number from this start value in this calculator, provided that we can do only 2 operations in this, right? So in this scenario, we can see that from 5 we can subtract 1, so that it will be 4, and then we can multiply by 2, it will be 8, right? So 2 steps are required. Similarly, another example, 3 to 10, how many steps do we need to reach 10, right? So let's see. There are multiple ways we can go, but what is the most optimal way to reach 10 from 3, right? So we can do is we can go 3 to 4, 4 to 5. Sorry, we can only subtract number 10, right? But how do we know like when to subtract? So one approach we could see is like we could just keep multiplying until it doesn't exceed the value, and then we start adding, right? But that will not be optimal. Some point there will be some scenarios where we have to subtract and then multiply again to reach the target value optimally, right? So for example, here say 12 and then 11 and then 10, right? So we can multiply until it exceeds this value, and then we start subtracting. But this is not optimal because this requires one extra step. So how do we solve this problem? Let's start thinking about the solution. So as we can see that from start point to end point, start to target value, if you go, we have basically 2 decisions to make, right? One decision is whether we want to multiply or we want to subtract every point in time. So one obvious solution would be like we can try all the combinations, right? So for example, we have a 3, we can go on multiplying. In each step we can either subtract 1 or multiply by 2 and see how many steps does it take to reach the target. And I'm not sure if this is even feasible. We can have some starting point like below which the value will not go, and it is very inefficient, obviously, because we are trying a lot of combinations. Another solution, if we think about it, is so if we start from first, we have these 2 operations, but if we start from target, will it make it easier? Like from target, if we are going to the start value, we either can divide it by 2 or add 1. These are the 2 operations we will be available with to reach to the start value. And does this helps? Like for example, for the same scenario, if we start from target and go to the start value, 8, 4 and then 5, we can obviously reach it in 2 steps. If we see from 10 to 3, we can go 10 to 5 to 6 to 3. 3 steps. So obviously we can do it, and does this eases our decision making process, like when do we want to divide and when do we want to add. For example, let's say it's divisible by 2, so we are dividing it, but this is odd right now, so we add 1 to make it even, and then again we divide, right? This is what we're doing right now. But is that the most efficient way? What if there might be in this process there might be some number where, like, instead of adding just 1 and making it even, we might add 3 and make it even, right? So 3 steps. Will there ever be a scenario where adding 3 instead of 1 and then dividing will help us reach to the solution faster? So let's say during this point we reach some, while dividing and adding, we reach some point x, which is equals to odd. So this is equals to 2y plus 1, right? So let's say the starting value that we are trying to reach is y plus 2. Okay, so in this case, this is the only solution or start value for which we might assume that adding 3 instead of 1 to make this number even, adding 3 instead of 1 to make this number even will help us reach faster. So if we add 3 here, so we have 2y plus 1, and then we add 3, that means we are doing 3 steps here, right? So this will make it 2y plus 4 in 3 steps, and then we divide it in the next step, which will reach us y plus 2. So we basically performed 4 steps here. But if we just add 1 in this value and calculate, so the next step it will be 2y plus 2, next step it will be y plus 1, and next step it will be y plus 2. So we reached here in 3 steps, right? From this x to this, we reached in 3 steps. If we just keep making this number even by adding 1 and then dividing and then again adding, we reach there in 3 steps. But this way, if we go, we reach there in 4 steps. So, and this is the only possible solution where it could have made sense to add 3 instead of 1. But for any other value, obviously dividing it would have made us reach there faster, right? So in all other scenarios, definitely this way is faster. So we have an algorithm now. So start from the target, right? So if target is even, target divide equals to 2, else plus plus, and every time we do this, we increase the step, right? So one more thing we notice is that, so from start to, while going from start to target, we can either multiply the start or subtract the start value, right? So if, let's say, start is higher than target, if start is 10 but target is 1, there is no way to use multiply in the start value. We can only subtract, we can only use this value, and since we are subtracting by 1, the solution would obviously be 10 minus 1, right? So another optimization we can do here is, we can do these two operations until we make target smaller than start, and once we do that, we can calculate the final answer, which is step and then the difference of start minus target. Let's see this solution in action. If it is even, then we can divide it by 2. If it is odd, then we can just add the target. And as soon as this target becomes less than or equals to the start value, the remaining steps would be just the difference between the target and the start, because at that point we can just do additions for the remaining steps, right? So this would be the solution. Let's run it and see if there is any issues. What happened? Output is 0. Oh, sorry, I forgot to increase the steps. Okay. So let's test it for one more value. Let's make it some random value. Okay. Nice. So as you can see, I'm documenting what I said in the previous diagram once again. So going from start to target is same as coming from target to start, but doing that will help us uh, determine like what to do at which step, because going from start to target value means we are actually increasing the value. So if the start is greater than target, we have the answer, which is uh, start minus target, right? If we start is greater than target, that means the answer would be this. But if target is greater than start, then we have to keep increasing the start by multiplication, or at some point of time we might have to do subtraction. So it's very difficult to determine when to do subtraction and when to do multiplication, because the values are basically increasing, right? It's a increasing spectrum. But if we come from target to start value, the values are actually decreasing, right? So it's easier to uh, work in a converging value set rather than increasing. So well, coming from target to start, target if target is even, we just decrease the target. I mean, we divide the target by 2. But if the target is odd, that point we have to increase the target to make it even, and then continue with the division steps. So that will help us reach to the start value the most optimal way, and that's how this problem is solved. Thank you guys for watching. See you guys in the next video.